All right. Next question, number 31, is talking about characteristics of sound waves. And this one, again, not too bad if you think about it the right way. We can knock off a couple of these right away. Right? Sound waves, number one, sound waves can travel through a vacuum. That is definitely not true because sound waves cannot go through space. Space is a vacuum. And number two, a sound wave is a transverse wave. That is very wrong. Sound waves are longitudinal waves. All right, the next two answers relate to energy. All right, now energy in sound relates to volume. Okay, higher volume will mean more energy. And volume, if you recall, is related to amplitude. All right, so here we have energy relating to amplitude, and that is a good one. Okay, when it says inversely related to frequency, there's a bunch of things that are inversely related to frequency. Period is inversely related to frequency, and wavelength is inversely related to frequency, but energy is not one of those things. So that can be a little tricky if you're not careful. Number 32, talking about tuning forks that are of the same frequency. And this is exactly what we did in class when we had the two sort of the two mallets with the xylophone bars. Because they were the same frequency, when you hit one, the other one starts to ring. That's because at the same frequency, you have resonance. All right, and that's just one you got to know. That is resonance. For number 33, this is a Doppler effect question. All right, Doppler effect. So it says that the astronauts are traveling towards the Earth. Okay, so if you are moving towards the Earth, your Doppler effect says you are going to have higher frequency, and higher frequency means shorter wavelength. Okay, that is straight up Doppler effect. Number 34, you have energy and matter exhibiting characteristics of both particles and waves. We talked about that. That a photon, for example, is both particle and wave. All right, whenever you get a question that it's talking about, oh, energy and matter exhibit, that's going to be both particles and waves. All right, particles and waves. Number 35 does not have to be tricky. It says which particles are not affected by the strong force. As long as you get the not, you're in good shape. All right. Strong force holds together particles that are in the nucleus. Okay, so right away, things in the nucleus, protons are in the nucleus, and neutrons are in the nucleus. So those are both out because they are held together by strong force. So we need something that is not in the nucleus. So you might think, well, what's a hadron? Well, if you look, a hadron is something that has made of quarks, okay? And if you have 3 quarks, you are a hadron. You could be a hadron if you have 3 quarks. And so that is protons and neutrons are both hadrons. Electrons are not in the nucleus, and so electrons are not affected by the strong force. Either